Hi there, this video is going to have a look at yet another problem where we need to work out the area trapped between two curves. In this instance, we've got y equals 2 sine of x and y equals x cubed minus 2x squared. Now, we can probably do some of this by hand if we wanted to in terms of, visualizing what 2 sine of x is and visualizing what x cubed minus 2x squared is. But the rest of the steps are going to be a bit tricky to do without a graphics display calculator. So that's what we're going to get stuck into. Just to remind you, though, they're the 3 steps. We want to visualize, we want to work out the points of intersection, and then we want to integrate. So let's switch over to the graphics display calculator. And I'm going to create a brand new document, and I'm going to add graph. Now, my first function is 2 sine x, so I'm going to put that in now. Bada boom. And then I'm going to go Control G to put in my second function, which is x cubed minus 2x squared. Minus 2x squared, like so. And there is our function. As we would expect, this one here bounces here at the origin. That would be the 1, 0 at x equals 0. And then it cuts through at x minus 1. And if you look at factorizing out the x squared, it'll probably give you a good sense of why that would be. So, excuse me. So there's the two functions in as we need them to be. I'll just pause for a sec. Sorry about that, just had a bit of a cough. So there's the two functions that have been graphed. And so we've got a visualization here. Now, even though I don't need to be too accurate with my graph here, but I would like to sort of concentrate on this area where they do overlap. So let me go to the menu here and go to Window Zoom, and we'll just go to Zoom in. And I'll just keep it in the middle of this kind of area here and zoom in. Can I go twice? Or just, yeah. And now we've got these two areas trapped nicely, like so. I'll just grab the graph a little bit. Like so. Okay, so, excuse me while I take a drink. I don't know if it's apparent to you or not, but what we have here is something different from other functions that we have studied so far. Excuse me, beg your pardon. What we have is not just one region, but two regions that have been trapped between the two functions. That's point number one. There's two regions, not one. What's the second point, do you think? Well, this first region over here is between this point and this point, but importantly, the red graph is on top. So the red graph, which is F2, and the blue graph, which is F1. So we're going to have to work out the integral of F2 minus F1 for this part of the graph. And then for this large region here, the blue graph is on top. And so we have to do F1 minus F2. Okay, so the order of the graph switch, because it's always the graph on top minus the graph on bottom. But you might note that we always start with the same idea, and that is we need the points of intersection. But we've got three. This one's pretty obvious, isn't it? But let's just go through the process anyway, just for the sake of it. So menu, analyze graph, intersection, go one side and then the other side, and there's my graph. Sorry, my point of intersection, like so. Just pop that out of the way there. The second one, for what it's worth, just to confirm, you could do it analytically, but either way, it's probably not a bad thing to just make sure that it's not 0.001 or something like that. But no, it is 0, 0. Like so. And then the third point of intersection, menu, analyze graph, intersection is just over here. grab the text and pop that over here as well. Now, what I'm going to do, and I'll switch over in a second, is I'm going to, over on my whiteboard, I'm just going to quickly draw the sketch, which I know you can't see, and just so that I've got reference for it here. It's not very accurate, it just gives me a sense of it. And I'm going to put those points of intersection in. So we've got x equals negative 0.687. We've got x equals 0, and we've got x equals 2.29. Okay, so I'm just interested in the x coordinates because they're going to help me work out my integration. And between negative 6.87 and 0, we have red on top, right? So that's the second function. So that's x cubed minus 2x squared. And then between 0 and 2.29, the blue line's on top, and that's y is equal to, or f1 if you like, is equal to 2 sine of x. Okay, so let's switch back over to Sketch, and you can see that in process here. So you can see if I just zoom out, I've got just a rough sketch of what the graphics display calculator told me. A little bit here and a big region in here. Really rough, right? It's just for context more than anything else as I'm writing up my solution. I haven't even put my x and y's in and all that kind of stuff. And here I've got my points of intersection with, I've just labeled which one is on top here and here. It's just to help me keep track of it. So now I'm going to do some working out. So the area, sorry, I'll just work in black. The area is going to be, well, that first region, right, which is going to be the integral from negative 0.687 to 0, and it's going to be the red on top. So it's going to be x cubed minus 2x squared, okay, minus 2 sine x with respect to x. So that's the first region, and I'm going to add to that the integral from 0 to 2.29 of 2 sine of x minus x cubed minus 2x squared. Now I'm going to take an extra step. I'm going to put a step in my head here. And I'm going to say, well, that's minus x cubed, and minus 2x squared is plus 2x squared dx, like so. Now we can't combine these at all because these have different boundaries. So there's no way of mushing them. We just have to do each of them in turn. And you know what? We could pretty much do this manually if we had to. But since we started with a calculator, why don't we just finish using the calculator as well? Now I've got it written down in front of me, so I'll be able to go into my calculator. And again, just remember, I'll just color code it. This bit here is the red graph, and this bit here is the blue graph. This bit here is the red graph, the blue graph, and this bit here is the red graph. Like so. Excuse me, we'll have another drink. And the reason why that's important is I wonder if you can remember from our previous video what we can do to make this a bit easier rather than having to write out those big expressions. So let me start by going to menu. Going to doc. I'm going to insert page. Excuse me. I'm going to add a calculator. I could have done it also by going control and then plus page here as well, control doc. Please excuse my voice. Now, the area is going to be the sum of those two integrals. So let's start off by getting the integral up like so and filling in the missing information. So we've got negative 0.687 to 0. And we just have to go red function, excuse me, which is f2 of x. Remember how we did that last time? We don't have to type in the whole thing. Minus f1 of x with respect to x. And we're going to add to that, the integral from 0 to 2.29 of f1 of x, because now f1 of x is on top, minus f2 of x with respect to x. And luckily it's put the brackets in for us, so we don't have to worry about that. So again, we've got the integral from this part of f2 minus f1, because f2 of x, the red graph, was on top. And then we've got from 0 to 2.29 of f1 minus f2, because the first function was on top for that second part, f1 of x being 2 sine x. And then press return, and we've got 4.63. Remember, these are signed areas, so that means that the area underneath the curve will be taken away from the top. 4.63026 is its entirety, or 4.63 to 3 significant figures, and that will be fairly accurate, like so. And we're done. So the graphics display calculator can make things a whole heap easier, and remembering that we can have these links between the two functions, between the two pages, to make our calculations a bit easier. f2 minus f1, f1 minus f2, and then we're good to go. So there's the wrap up there. Area equals, my equal sign's not very good there. Area equals, and then the graphics display calculator has given us the response, and then I've approximated to 4.63. Okay, so the next example I give you, which will be in a separate video, will be doing it by hand rather than using a graphics display calculator. Thanks for watching.